Hello, Joe. What's going on? Joe, did you see my video on Mario Brothers? Alright, he just starts singing, then he walks away. What's up? Well, yeah, I was waiting for you to come back. I mean, not in this video. My lesson will start at 1:10. I'm going to be teaching. But I am currently playing a game to pass the time because I thought you were here. Did you see my Super Mario Bros. Run that I posted? Hey, Kyle made it. Here, let me try and find the link. There we go. Paste. My lesson will be starting in approximately 3 minutes. But y'all should go watch that video of me beating Mario Bros. In five and a half minutes. Definite room for improvement. Definite room for improvement. You should go watch it again, Kyle. Should open like 5 windows and have them all open at once. I really don't know if that'll do anything. I'll have to do a live stream of me doing that, just so I can get a time. I feel pretty confident that I can get I can beat 527 in a live stream for Mario. Maybe, if I have time, maybe I could do that tonight. Joe, maybe our friend from Malaysia will be up tonight. Oh, I gotta get started. Alright, hold on. Let me finish one thing up, and then I'm gonna get started with my lesson. Yeah, I'm done with that. Okay. Let's close that out. Boom. Boom. Move that over. Okay. Good. Alright, so we're going to get started with this. It's 110. We are going to get moving with this lesson. So, there we go. In the description to this video, there is a link to a worksheet that looks like this. And this worksheet is where I will be working. I'm not going to be working, putting my work on this piece of paper, but these are where all of my problems are going to be coming from. Joe, when you say pretty good, are you saying appropriate? What do you call a person who refuses to fart in public? I am almost terrified to ask what. I'll wait for Joe's answer and then we'll get moving. So, oh, he did? He did tell us this? Whatever. I'm going to wait for Joe's answer so I can block it if it's inappropriate. Okay, I'm going to steal that joke. That's decent. Okay, back to me. So, in this worksheet, there are 15 problems. There are a couple of problems that in my lesson for discrete math, I did not teach. I did not teach geometric infinite series. That is okay. The worksheet that I assigned my discrete math class was a practice worksheet. It was designed to be a practice worksheet. I said it would not be graded. I wanted them to attach their work to the Google Classroom assignment and submit it that way. And as long as they did, they're fine. They're totally fine. I even gave my discrete math class, if you're listening to this at the beginning, at a later date, I even said that if you wanted to, you could go through the problems with me here. That's perfectly fine. It's just a practice assignment in preparation for the real assessment. So, number one. Number one says to find the 10th term. I'll number them like this so that we can identify them in the timestamps that I'm going to put later. It says to find the 10th term of an arithmetic sequence. Now again, being that it's arithmetic, is very important to be able to identify because arithmetic implies that it is going to have a linear pattern. Find the 10th term of the arithmetic sequence in which a sub 1 equals 5 and d equals 4. This is a fairly straightforward question. Since arithmetic sequences have a linear pattern, linear equations, you only need a slope and a y-intercept in order to write the equation. Well, for arithmetic sequences, you only need a first term and a common difference, which, in number one, they already give you. The formula, which I'm going to write out the formula for what I'm using when I'm using it, for the equation of the nth term of an arithmetic sequence is this. in which a sub n equals my first term plus n minus 1 times my common difference. I'm going to get rid of Joe's joke here. Remove. There you go. Okay. So I just need to simplify this. This would really be 4n minus 4. So the formula would end up being 4n plus 1. Of course, you can check yourself, mainly being that since arithmetic sequences are linear, the slope should match the common difference. But then also, if you plugged in a 1 for the first term, it should result in a 5. And it absolutely does work. Now, that's not what the question was asking. I don't even know why I thought that, but that's the common formula. But then the question wants the 10th term. The 10th term, plug a 10 in, should be 41. Now, obviously, you don't really need to get this particular formula. If the common difference is 4, you could just add 4, add 4, add 4, add 4, add 4 until you get to the 10th term. But, in my opinion, going after the formula is the better path, only because what if they didn't ask for the 10th term? What if they ask for the 500th term? Then that formula will come in handy. It's very helpful. Let's look at number 2. Number 2, again, you can see these problems in the PDF link in the description of this video. A water tank is emptied at a constant rate. At the end of the first hour, at the end of the first hour, 36,000 gallons of water were in the tank. After 6 hours, 21,000 gallons remained. How many waters were in the tank at the end of the 4th hour? Now, this... sorry, I'm looking at the chat now for some reason. I should not be looking at the chat. But for a problem like number 2, this is like the type of problem that you would see in Algebra 1 or something along those lines. It's a linear type of problem where they're just basically saying, well, at the end of 1 hour, there were 36,000 gallons. After 6 hours, there were 21,000 gallons. And then they want to know, well, how many gallons were at the end of the 4th hour. If you wanted to find that slope or common difference, what have you, you could do a calculation like this. What would that be? 16, 15, negative 15,000? Negative 15,000, which is what? Negative 3,000? I want to say. I'm going to double check those. Just because I'm fairly confident I got that. I just want to make sure. I don't want to make a mistake. Yep, negative 15,000 divided by 5. Yep, negative 30,000. 3,000. Good. Now, that's the rate of change. That is the common difference. That is your slope. Again, if you wanted to, you could start subtracting 3,000 from this ordered pair until you get to 4 hours. If you wanted to, you could also find the formula. Plus parentheses n minus 1 times negative 3,000. And then we could easily just plug in a 4. In fact, let's just do that. So it really should just be a sub 4 is equal to 36,000 plus 3 times negative 3,000. I'd probably do this in my head. That really should be, what, 27,000? I'm just going to double check that. Double check that it's 27,000. Yep. There are much simpler ways to do a problem like this with just x and y and y equals mx plus b, or just recognizing that it's subtracting 3,000 every single time in order to get to 6 hours, and then you just subtract 6,000 until you get to hour 4. But if you're utilizing what I taught in this lesson, then this is the work that you could do. Word problems are strange. Let's look at number 3. Number 3. Now this is where it takes a bit of a turn. They want you to find S sub n for an arithmetic series in which, so find S sub n in an arithmetic series where the first term is 37, the number of terms that you're adding up is 11, and the common difference is -3. Oh, Kyle, what game are you talking about? Anyway, so the formula that we're really in mind for, because it's arithmetic, would be n parentheses a sub 1 plus a sub n over 2. Now in this case, yes, we know what n is, and we know what a sub 1 is, but we do not know what a sub n is. A sub n represents the last term that you're adding up, and they want you to add up 11 terms. Now, again, if you wanted to, you could start counting from 37 and subtract 3 every time until you get to the 11th term, or you could very easily do something like this. What I just utilized in the top right portion of this worksheet was your a sub n equals a sub 1 plus n minus 1 times -3. By doing that, which by the way, I know a sub 1 is 37, I could have just written that, but by doing that, you can find that last term that you're looking for, which in this case should be 7. The sum of the first 11 terms, if I'm utilizing this formula, would be 11 times first term plus the 11th term divided by 2. Should be what? 42 divided by 2, which is 21. 21 times 11, which is... Oh, wait, no, I'm sorry. It wasn't 42. It was 44. 44 divided by 2 times 11, which is 242. That would be the sum of the first 11 terms. Now, again, if you wanted to, I don't know anyone who would do this, but you could add them all up right here. 37 plus 34 plus 31 plus 28. I'm not going to do this for every single one. 25 plus, was that 5 terms? 6 terms, 7 terms, 8 terms, 9 terms, 10 terms, and 11 terms. That would be the series that you would be adding up. And you can see 7 being the last term. You can see there being 11 numbers being added up, 242. But again, instead of having to write that all out, instead of having to type that all out, what if you were adding up 100 terms? It's much easier to go about this process utilizing the formulas that were given to you. Let's talk about number 4. Number 4 switches it up and goes to geometric. So, if we're talking geometric, they want you to find the 6th term in a geometric where a sub 1 is 5 and r is equal to 2. The formula for geometric, which I wrapped up, I did a wrap up at the end of the lesson video that I did for this, a geometric nth term formula would look like this, where it would be the first term times the ratio to the n minus 1 power. Now, you're going to have to evaluate r to the n minus 1 first, then multiply it by the first term. So a sub 6 is equal to my first term, which is 5, times r, which they told me was 2, to the 6 minus 1 power, which is really to the 5th power. That should give me 32 times 5, 160. Now, obviously, the first 8 problems were multiple choice on this particular worksheet. Again, that worksheet, the link is in the description. But I like figuring these things out by hand. I'd rather not just guess and check. I like utilizing the formulas. These formulas are very helpful. People have spent a long, arduous time proving that these formulas work, and why not use them to our fullest advantage. The types of problem-solving skills that are needed in this particular chapter are basically, well, what formula do I need to use? How do I use it properly, depending on the situation that's in front of me. Let's talk about number 5. Number 5, they want you to find a sub 1, find the first term in a geometric for which series which is s sub n is equal to negative 728, r is equal to 3, and n is equal to 6. Nice. So they want a sub 1. The formula for the sum of a geometric series is as follows. And again, this was outlined in that video. It is entirely within reason to be given a formula sheet when going through problems like this for an assessment if we were in class, but obviously we're not in class. So if you're doing an assessment at home or online or quizzes, what have you, having that formula sheet out is very helpful because you don't want to mess up a single term in this. So now, s sub n equals negative 728, which means this is negative 728, equals a sub 1, because I don't know what a sub 1 is. They want me to find a sub 1. 1 minus 3 to the 6th power over 1 minus 3. All I did was take the formula and plug in the numbers into their appropriate locations. This should be negative 728 equals a sub 1 times some ridiculous number. Let's just see what we get here. 1 minus 3 to the 6th divided by negative 2, which is 364. Be careful of your negatives and your positives. Divide both sides. Boom. Your first term is negative 2. Joe, are you sleeping? Anyway. I don't know if he's yawning or not. I'm going to show that one. There you go. He just likes showing off smiley faces. Anyway. Of course, as always, again, I keep saying this, but you could work backwards if you wanted to. Here's one way of working backwards. Well, actually, for this problem, working backwards would be a bit difficult. They tell you the common ratio and they tell you the number of terms, but they don't tell you where you start or where you end. The only thing that they tell you is what it adds up to. Yeah, on second thought, yeah, that's not as simple as doing that. You're going to have to utilize the formula in that case. Number 6. Number 6, all they ask you to do is to evaluate this. Now, there's a few things that I have to say about this. First, the question you must ask yourself is, well, okay, what does that giant symbol here mean? This is sigma. This means the sum of. I have to add up a bunch of stuff. Okay. What am I adding up? Well, I'm adding up a sequence that is governed by this formula. What type of formula is that? That is an arithmetic sequence. It's arithmetic, and I can recognize that because it's linear. Now, the sum of the sequence governed by this formula, starting at the 7th term and finishing at the 15th term. Now, there's two ways to go about this. You could start by just plugging in that 7. You get 16. And then, I don't know, go to 8. You go to 8, plug it in. What do you get? 19. You go to 9, plug it in. What do you get there? 22. Now you can see what's happening here. 16, 19, 22, that represents the slope or the common difference of 3. But I would have to keep going until I got to the 15th term. I don't really feel like doing that. How many terms am I even adding up here? Can't say I'm adding up 15 terms. Instead, think of it like this. If I'm to go to the 15th term, you could say, oh, well, there's 15. No, you can't say 15 terms because I am not counting the first 6. Not counting the first 6. Which means, in reality, n is equal to 9. N is equal to 9. A sub 1, my first term, was 16. That's what that first term was right there. You could plug in a 7, you get 16 back. My last term, which technically is the 9th one in the series, I'd have to plug a 15 in. You plug a 15 in, what is that? 45 minus 5, which is 40. Well, this is arithmetic, which means that I'm going to be utilizing this formula in order to get this done. That's what this is really asking me to do. You could list out all of the numbers, but instead of listing out all the numbers, why not utilize the formula? The sum of the first 9 numbers is equal to 9 times 16 plus 40, the whole thing over 2. Plugging in the appropriate numbers into the appropriate location. 16 plus 40 divided by 2 times 9, 252. That's what that problem's actually asking you to do. It's important to recognize, again, yes, sigma is the sum of, but more importantly, this is arithmetic, which means I have to use this formula. I'm going from the 7th term to the 15th term. I'm not counting the first 6, which means I'm only adding up 9 total terms. That's why n is equal to 9. The first term is technically I've got to plug a 7 in. The last term, technically I got to plug a 15 in. And then I just plug and chug from there. Number 7. Number 7 wants me to find the sum of a geometric. So it's important that we recognize this is geometric. And the thing that they give me is 512 plus 256 plus 128 plus ... And they want me to add up 6 terms. Okay. What's the common ratio? To go from 512 to 256 to 128, if I find the ratio between consecutive terms, 0.5. Could have done that in my head. Or 128 divided by 256, 0.5. My common ratio is 1/2. My a sub 1 is 512. The reason why I wrote all those out is the sum of a geometric is equal to the following formula. It's not vital that I write out the formula every single time, but it's helpful. Because if you write out the formula every time you use it, you're more likely to remember what it looks like, how it's structured, and it's just helpful. Let's plug and chug. The sum of the first 6 terms is equal to 512 parentheses 1 minus 1/2 to the 6th power. I'm going to have to be careful with that when I calculate this. Over 1 minus 1/2. Let's see what happens. Now, when I calculate this, I'm going to put that 1/2 in parentheses. There's the top of the fraction. Divided by parentheses 1 minus 1/2. You could put that in, I'll put it in parentheses too. There we go. Times 512. Nice. In the middle of those calculations, it doesn't seem like the numbers are going to work out perfectly, but they do. It doesn't seem like it, but they do. We just have to be careful with how we calculate this. It may be helpful. Instead of doing 1/2, you could do 0.5 in this case. That was 8. Still, obviously. Personally, I like using fractions only because what if the fraction was like a 2/3? I'd like to get an exact number, and to do the exact number, I'd rather use the fraction. But again, to each his own. Let's talk about number 8. Find the sum of the arithmetic. So they want the sum of an arithmetic. Again, changing gears, linear pattern instead of exponential. With 23 plus 18 plus 13 plus dot 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 plus negative 82. For the sum of an arithmetic, I need to use the following formula. I need to know the number of terms being added up. I need to know the first term, and I need to know the last term. I know the first, I know the last. I don't know how many terms are being added here. Yes, they're being subtracted by 5 every single time, but I don't know how many terms are being added up here. The best way to figure that out is by utilizing the original formula that we used for the formula for the nth term of an arithmetic. Now, a sub n is what I'm trying to figure out, but a sub n is my last term. A sub 1, 23, plus, I don't know what n is, but I do know that my common difference is negative 5. This is how we're going to be able to solve this. So, negative 82 equals 23 plus, nope, minus 5n plus 5. Be careful there. That's really a 27. Yeah, minus 27, negative 109. Oh, I'm sorry, that's a 28. My bad. That's up to a 28, so it's really negative 110. Negative 110 equals negative 5n. Boom. N is equal to 22. In a problem like this, the number of terms has to be a positive whole number. It has to be a positive integer. Since you can't have a fraction of a term, the number of terms has to be something like that. So, knowing that I'm adding up the first 22 times the first term plus the 22nd term, which I knew was negative 82 divided by 2. At this point, it's just plug and chug. The journey to get to these answers, the journey getting there is one thing. There we go. Negative 649. The journey getting there is going to be the key. Once you have all the numbers, it's just a matter of plugging and chugging. It's a large negative number, even though, yes, it does start in the positive range, but then once it drops below negative, it's just adding more and more negative numbers to it. Okay. Now that completed the multiple choice problems. But let's talk about some of these free responses. Again, worksheet link is in the description. Let's talk number 9. Write an equation for the nth term of the arithmetic sequence 5, 3, 1, negative 1. Okay. They just want the formula. It's pretty straightforward. The formula has the following form. Again, I'm writing it down every time I'm using it. That's just my thing. I need the first term, and I need the common difference. Quite clearly, the common difference is negative 2. Negative 2 every time. So, first term plus parentheses n minus 1 times negative 2. Let's clean that up a bit. Be careful with your positives and your negatives. Negative 2n plus 7. You got to be very careful with your positives and your negatives. In order to check your work, in order to check to see if you did it correctly, it is a good idea to sometimes plug in some numbers, like the fourth term. The fourth term should be this. So if I plugged in a 4, negative 8 plus 7 is negative 1. And it works. You could always check yourself in that fashion. Sometimes it's a good idea. Number 10. Now, number 10 is not something that I taught. Number 10 is not something that I, well, quite clearly did. But I will explain it to you right now. They want the 4 arithmetic means between 22 and 2. Now, what that means is this. They're saying there exists an arithmetic sequence where there's a 22 and a 2, and there are 4 terms in between them. That's what they're really saying. How did it go from 22 to 2? How do you do it while maintaining an arithmetic sequence? Well, this is a sub 1, this is a sub 6. If that's the case, then 2 minus 22 over 6 minus 1 equals negative 20 over 5. D is equal to negative 4. And since D is equal to negative 4, well, what are the 4 arithmetic means between 22 and 2? 18. That's an 8. There we go. 14, 10, 6. Minus 4, minus 4, minus 4, minus 4. It's not something I taught in that video. I may have just skipped over it for some reason. I'm not sure why. But you can do the exact same thing for geometric, although they don't ask a geometric problem with geometric means. Geometric is a bit crazier. It's not as straightforward, especially with positives and negatives. But this is what we get. There are the 4 arithmetic means between them. Find the common difference, count them down. Let's talk about number 11. Number 11 wants you to write an equation for the nth term of a geometric. So they're telling you it's geometric. 40, 20, 10. Just by visualizing the problem, you can see that r is equal to 1/2. Times a half times a half, or divide by 2, divide by 2. But in reality, they want r to be 1/2. You can't say divide by 2 is the ratio. Divide by 2 might be the pattern, but dividing by 2 is not the rule. Only because to find the rule, they want that formula, which in this case should look like that. I need the first term, I need the common ratio. Okay. A sub n equals first term times 1/2 to the n minus 1 power. There's no simplifying needed. You don't make that a 20. If you make it a 20, it's wrong. You can leave it just like that. You have to evaluate the 1/2 first with the exponent, then multiply by 40. Number 12. They want you to evaluate the following. Now, we did a problem similar to this earlier. This symbol sigma means the sum of. The sum of this sequence, which you have to recognize as geometric based on that form. The sum of the geometric sequence starting from n equals 1 and finishing when n equals 6. You could plug in a 1, 2, 3, 4, 5, 6, get those 6 terms, add them up. Or, my opinion, you'd be much better off utilizing this formula. You need the ratio, which is 3. You need the first term, which is 2. And you need the number of terms, which in this case, since they're starting at 1, it's fairly easy, 6 terms. The sum of the first 6 terms is equal to, well, keep in mind it has to be the same form. A sub 1 times r to the n minus 1, which it is. But, just to be sure, if you wanted to double check that you got the correct first term, you plug in this number, you get 3 to the 0, which is 1, times 2 is 2. Always double check that. 1 minus 3 to the 6th over 1 minus 3. Which, again, go into the calculator. 1 minus 3 to the 6th divided by -2 times 2, 728. I feel like we had a problem like this earlier today. What number was that? I feel like we had something very similar to that. Oh yeah, it was number 5. Number 5 was similar, but not exactly the same. Number 5 was very similar. Yeah, except there was a negative involved. If you look back at number 5, it was geometric, it had the same ratio, it had the same number of terms, except they added up to a negative number. Which most likely means they wanted, oh yeah, a sub 1 should have been -2, which is what the answer was to that problem, but that is neither here nor there. Let's talk about number 13, and then after number 13, I want to spend a little bit more time with 14 and 15, since those were things that I did not teach. Number 13. Find the first 3 terms of an arithmetic series. So it's arithmetic, meaning linear, meaning all the formulas that they've given us so far, in which n equals 12, a sub n equals -41, and s sub n equals -228. Okay. Because they gave you the sum, that is an indicator to me that I should be utilizing this formula. S sub n is -228. N is 12. I don't know what a sub 1 is, but I do know that a sub n is -41, or the 12th term, I should say. If I solve that, that'll get me the first term. But they do want the first 3 terms. So I'm going to have to deal with that in a minute. I will have to deal with that in a minute. Yes. Okay, let's find that first term. Peel off the layers. Just like you were back in algebra class, I'm going to divide both sides by 12. I'm going to multiply both sides by 2. And I'm going to add both sides by 41. What I just did, I divided both sides by 12, so I get -19 equals a sub 1 plus -41 over 2. I multiplied both sides by 2, I get -38 equals a sub 1 plus -41. I added 41 to both sides to get the first term at 3. But they want the first 3 terms. In order to find the first 3 terms, I'm going to need the common difference, and I don't have the common difference. I don't have the common difference. So what I'm going to need to do, again, this is part of the problem solving that I'm referring to. This is what makes these problems a little difficult. Basically, the question you have to ask yourself is, what do I do next? Well, I have this formula for an arithmetic, which has d in it. I have a sub n, the last term. Now I have a sub 1, and I know the number of terms. I can solve for d. Subtract 3, divide by 11, d has to equal -4. From there, it's fairly straightforward. They want the first 3 terms, which are 3, -1, -5. You just subtract 4 every time, because it's arithmetic. If you did that, I believe it would definitely work where you'd get to -41 for the 12th term. And then, of course, adding them all up, which I don't have to, because they already gave me that. Now, 14 and 15 are strange. 14 and 15 deserve a little bit of explanation. Here's what it comes down to. An infinite geometric series, meaning a series that keeps going forever and ever and ever and ever. which, for example, I'll use number 14. 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4 plus 1/8 plus dot 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 dot. Here's the deal. There will always be a time which you add stuff to it. This series will continually add positive values to the total. For example, if you took 8 and 4, watch this. 8 plus 4 plus 2 plus 1 plus 1/2 plus a 4th plus an 8th plus a 16th plus a 32nd. Look what's happening. I keep adding positive values to this. But would you believe in your heart of hearts that if I kept doing this forever and ever and ever, if I kept doing this, watch, I'll do one more, the total would just be 16. You can see that by what they equal. It keeps getting closer and closer and closer to 16. But if you added up an infinite number of numbers, the grand total would just be 16. It's kind of ridiculous to think. Think of, and I've done this example in my classroom with other classes, but obviously we're not in my classroom. Imagine a door. There's the door in my classroom. And there's me. Clearly not accurate, because I've been inside for 2 months. Watch, I'll add a beard. There. There's me. With little hair. But anyway. Let's say that I am a grand total of 16 feet away from that door. A grand total of 16 feet. Now, I am going to walk half the distance and stop. How far have I walked? I've walked 8 feet. Then, I'm going to walk half the distance and stop. So this is 8, and this is 4. I've walked 12 total feet. Half the distance and stop. Half the distance and stop, etc., etc., etc. Theoretically speaking, if I continued that game of walking half the distance and stopping, I would never reach the door. Theoretically, I would never reach the door. There would always be some positive distance between me and the door. I mean, clearly, I can just reach out and touch the door, but that's not the point. There will always be a positive distance between me and the door, unless I am allowed to take an infinite number of steps, which clearly, in real life, I can't. I can't take an infinite number of steps. But, in an abstract way, I can take an infinite number of steps. And if I were able to take an infinite number of steps, what is the grand total distance I would have traveled? 16 feet. Which, by the way, is the answer to number 14. Now, I'm not going to go into the details as to how they came up with this formula, but for the sum of an infinite geometric series. Well, it's not even n there. There's nothing there. I'm going to cross that out and try again. There we go. The sum is just equal to, because there's no n. You don't know how many terms you're adding, because it's an infinite number, and infinity is not a number. But it's equal to the following calculation. A sub 1 over 1 minus r. Now, there's a caveat to this. There's a huge caveat to this. R has to be between 0 and 1 in this case. R has to be between 0 and 1. It's strange. Strange little thing. But the reason being, if you had an R value that happened to be, let's say, greater than 1, then what would end up happening if you had an R value that was greater than 1 is, like, let's say 1, 2, 4, 8, 16, etc., and it just kept going on forever. If that were the case, then being that it never stops, the sum would just keep getting larger and larger and larger and larger, and there's nothing you can do to stop it, for the lack of a better term. Now, I'm actually trying to look something up real quick, because I want to make sure I'm refining that definition of an infinite geometric series. I just want to make sure that I'm right. I mean, I'm fairly certain I'm right, but I'm just double checking one specific outcome of it. Oh, yes, of course. Of course. I'm going to have to modify this ever so slightly. I will have to modify this ever so slightly. Yes. Let's modify it like this. Wait. Yes. There we go. I had to think about that. My brain is not working today for some reason. Now, R can technically be negative. R can technically be negative, and I will show examples like that another time, which is perfectly acceptable. Again, just doubt myself sometimes when it comes to this. Yeah. If the value of R is actually greater than 1 when you take the absolute value, then it will not work. Just keep that in mind. If you were going to do this problem right here, it would be 8 divided by 1 minus the ratio, which is 1/2. This would be 8 divided by 1/2. Again, you got to make sure you type it in correctly. If you typed it in like this, you would be wrong. 8 divided by 1/2. Now you are right. Yay. Which is why the answer to number 15 is it doesn't exist. Number 15 is it doesn't exist, because the value of R is greater than 1. The absolute value of R has to be less than 1, and that one's greater than 1, so you can't do it. Okay. Now, Joe fell asleep in the chat. I'm assuming Kyle did as well. I don't know. Maybe they're doing other things. But this concludes the lesson for today. I may or may not be on later tonight. Let me leave a comment in the chat just in case they decide to come back. I may or may not be back on tonight to speed run video games. We'll see. 8 p.m.-ish. There we go. But other than that, haha, Joe, you did fall asleep. But other than that, I'm going to stop it from there. And I'll see you guys later.